Yeah, hi everyone, welcome to PrepFusion. So it is a very famous interview question that what will happen if we showed the input and output of a CMOS inverter. So already I have tried to make a video, but let's make it again. So what will be the first impression, what people will think that sir it is an inverter? No, sir it is an inverter, right? Since it is an inverter, I will make an inverter and input and output are shorted. Let's just say I have made this inverter, this is the input, this is the output. So if I short them, what should happen? Sir, here if I break the circuit here, if I break the connection and I apply input 0, then what will this inverter will do? It will convert it into 1, and now because of the feedback loop, this 1 will again come back. Then 1 will be converted to 0. Then sir again 0 would come back. Then this 0 will be converted to 1. So sir, at the output what I am getting? 1, 0, then 1, 0, 1. So it will work as a clock generator circuit, and this is what a lot of people would think, and this is what a lot of people would answer, but it is wrong. Okay, it will not work as a clock generator circuit. If you want to generate a clock, you will have to use at least 3 inverters. Why is that so, sir? That we will check out. Okay, so it will not work as a clock generator circuit. This particular circuitry would work as a clock generator. Okay, so this is the actual clock generator, not this. Why is that so? Let's check that out. Okay, so we will take some assumption for the easier explanation that VDD is 5 volt. Okay, and we are taking the threshold voltage of PMOS and threshold voltage of NMOS both equal, and both equals to 1 volt. Okay, so threshold voltage we are taking as 1 volt. Understandable? Now this is your output and this is your input, and both we are shorting. So only one node would be there, no? So we are shorting both of them. In the gate examination as well, this question has been asked. That's why I thought that let's make a separate video. So both we are shorting here. Okay, so let's remove this V in input because it has been shorted, no? So only one node I will make, that is V out node. Understandable? Now at the output what I can do, I can assume a capacitor. Like this CMOS inverter will have further stages as well, no? This will have further stages. So some load would be there. So a load capacitor I can assume here. Always I can assume a load capacitor. So what will happen now? Initially this load capacitor is uncharged. Initially how much voltage it is having? This load capacitor is having 0 volt. Now what will happen? This 0 volt will travel. Here it is grounded, then it is having 0 volt. This 0 volt will travel and this 0 volt will reach here. This 0 volt will reach here as well, and it will reach here as well, and it will reach here as well. I am converting VDD into 5 volt. Now upper one is PMOS and downward one is NMOS. So as of now, what is the VSG value of PMOS? VSG is nothing but 5 volt. VSG is 5 volt. And one more thing you would see that, sir, input and output are shorted. So I have shown the connection like this, but I could have shown the connection like this as well, no? Are you able to understand this point? If I say that I don't want to show this connection, I don't want to show this connection, I want to show the connection like this, is there any issue? No. Input and output are shorted. No, input output are shorted. That I need to short. That's it. So input output I need to short. So this is how I can show the connection. So initially there is 0 volt. This 0 volt has traveled. This 0 volt has reached here, and this 0 volt has reached here. So VSG is 5 volt here. What is the VT value? VT is 1. So VSG is greater than VT. Along with that, it will be in the saturation region always. Why is that so? Because gate and drain are shorted. This is the drain of PMOS. This is the gate of PMOS. This is the gate of NMOS, and this is the drain of NMOS. And this is the source, and this is the source here. So if gate and drain are shorted, then PMOS or NMOS both will be in always saturation region. So they will be always in the saturation region. Always they are in the saturation region. This is the first thing, that they are always in the saturation region. So now it is turning on. Because VSG is greater than VT, it is turning on and it is in the saturation region. That means it will drive some current. Some current it will drive. In which direction it will drive the current? From higher potential to the lower potential. That means in this direction it will drive some current. What about the NMOS? What about the NMOS? This was the scenario for PMOS. What about the NMOS? What is the VGS value now? VGS. This 0 volt has reached here. So this is also 0 volt. This is also 0 volt. Both grounded. VGS is 0 volt. What is the VT value? VT value is 1. What does that mean? It is off. That means it will drive 0 current. Here it will drive some current. It will drive some current. I don't care about the value of the current, but this will drive 0 current because VGS value is 0. Here VGS value is 0. So now some current is being driven from the upper side. Some current is being driven. Now this particular circuitry is taking 0 current. Then where the current would go? The complete current would flow through the capacitor only. Now because of this current, what will happen? Capacitor will start charging. Let's just say the capacitor has charged to 0.1 volt now. Capacitor has charged to 0.1. Initially there was 0 volt, 0 volt has reached here, this turned on, this is turned off, then current started flowing and this has charged to 0.1 volt now because of the current. Now what will happen, this 0.1 volt again will reach here because of the direct connection, it will reach here and it will reach here as well. Now what is the scenario? What is the scenario? For PMOS, what is the scenario now? What will be the VSG value? 5 minus 0.1, 5 minus 0.1. So VSG value will be 4.9 volt. What will be the VT value? 1 volt. Saturation region, some current would be driven. What about the VGS value? VGS has become 0.1, 0. Yes, 0.1 volt. VT value is 1 volt. No current. Current is 0. Now since this VSG value has gone down, the value of current will go down. But the direction is same. No, again the direction is from up to down only. The value of current will be going down. Why is that so? Because what is the current equation? What is the current equation in saturation region? Sir, some parameter divided by 2 VSG minus mode of VT whole square. This is the equation, no? So this VSG value is going down, so value of current is going down. But doesn't matter, value of current is going down, but the direction is the same only, no? So capacitor will still charge. Capacitor will keep on charging. So capacitor will still charge. Now from 0.12 it will go to 0.2, 0.3, 0.4, 0.5. What will happen is that VSG value will keep on going down. This VSG value will keep on going down. Let's just say it has went to 0.2. So now what will happen? This 0.2 will reach here. This 0.2 will reach here. So now for this VGS value will become 0.2 volt. And here VSG value would become 5 minus 0.2, 4.8 volt. Right? So in that manner it will keep on going. It will keep on going. Still it is off. Still it is on. Then it will keep on going. Let's just say it has reached to 1 volt. Let's just say it has reached to 1 volt. Now what will happen? This 1 volt will reach here. 1 volt will reach here. This 1 volt will reach here. This 1 volt will reach here. So 1 volt has reached here. So what will be my VSG now? This will become 4 volt and this 1 volt has reached here. My VGS will become 1 volt. Now what is the scenario is that? Now my scenario is that VSG has become 4 volt. VT is 1 volt. Saturation region current will be driven. And what about NMOS? VGS has become 1 volt. VT is also 1 volt. Now, yes, it will turn on. So, yes, very small current it will drive. Let's just call it 1.1, 1.01 you call it. 1.001 volt. So, VGS is greater than VT now. Right? VGS is greater than VT. That's why it will drive some current. So, now it has started driving some current. But who is dominating? Here he is having very high VSG, no? Very high VSG. So this current, let's call this current as I1, this current as I2. So I1 is greater than I2, no? I1 is much greater than I2. So what is the scenario is that he is also driving some current. NMOS is driving some current. Along with that, PMOS is also driving some current. PMOS is also driving some current. Both are driving the current. At 1 volt, when the capacitor is charged to 1 volt, he is driving some small current, I2, but he is driving some large current, I1. So let's just say from the upper side 5 ampere current is coming and downward side only 1 ampere current is going. That means again capacitor is driving 4 ampere current. Are you able to understand this point? From the upper side large current is coming. 5 ampere current, 5 milliampere current is coming. Downward there is only 1 milliampere current. That means in the capacitor how much current would flow? Apply KVL here, no? Apply KCL here. 5 here coming, 1 going here. That means 4 will go here. So again capacitor is getting charged. So capacitor will keep on charging. Capacitor will keep on charging. At what point the capacitor will stop? Let's just say both of the transistors are identical. Both of the transistors are identical. Now the capacitor has reached to, let's just say the capacitor has reached to 2.5 volt. 2.5 volt. I am assuming both of the transistors as identical. So capacitor will keep on charging from 1 volt to where it will go. From 1 volt to where it will go. Let's just say after 1 volt it has went to 1.2 volt. Then what will happen? This 1.2 will reach here. 1.2 will reach. Then what will be the VSG value? So 1.2 volt will reach here and 1.2 volt will reach here. What will be the VSG value? VSG value will be nothing but 3.8 volt. VT is 1 volt only. Yes, some current is driven. What about NMOS? VGS value will be 1.2 volt. VT value is 1 volt only. That means yes, it will also drive some current. Let's just say this current was I1, this current was I2. Again I1 is greater than I2, no? Again I1 is greater than I2. Say yes or no? Why is that so? Because VGS is large, no? Here this VSG value is large. If this is large, that means this current would be more. Here it is lesser, so this current would be lesser. This current would be more. So again I1 is more. that means this value is again more, this value is again less, that means some current again would flow, again it would flow, again it would charge, it will keep on charging, it will keep on charging. Let's just say it has reached to 2.5 volt. Now what will happen? This 2.5 volt will come here, this 2.5 volt will come here as well. Where it will come? This 2.5 volt will come here, 2.5 volt will come here. Now torque. Now you do the torquing. What will be the VSG value now? 5 minus 2.5, sir, it will be 2.5 volt. What will be the VT value? VT value will be 1. For NMOS, what will be the VGS value now? 2.5 volt. And what will be the VT value? 1. If I am saying that both of them are identical, that means yes, both will drive the current. This will also drive the current. This will also drive the current. What will be the value of I1? I1 will be, sir, Kp by 2. Kp is the parameter, right? Mu p Cux W/L. Kp is mu p Cux W/L. VSG minus mod of Vt whole square, right? And what will be I2? Kn by 2 VGS minus mod of Vt whole square. I am saying that both of the Vt's are same. Along with that, I am saying that Kp equals to Kn as well. If this is also same, this is also same, this is also same, everything is same, what does that mean? I1 will turn out to be equals to I2. And if both are same, if I1 and I2, if both are same, that means from upper side, let's just say 2.5 milliampere current is coming, the same current is going downward as well. The complete 2.5 milliampere current is going downward as well. What does that mean? Through this capacitor, there is 0 milliampere current. What does that mean? Capacitor will not charge further, and this will be the steady state value. And this will be the steady state of the capacitor. So if someone would ask that what will happen if the output of a CMOS inverter is connected back to its input, then initially the PMOS will turn on, it will start charging the capacitor, it will keep on charging. At some point of time, NMOS will also turn on, the NMOS will also start driving some current. The current in the capacitor will keep on going down. At some point what will happen is that the current in the PMOS and current in the NMOS will become same, and at that point the capacitor will not charge further, and that will be the steady state value of the capacitor. So is it acting as a stable multivibrator like 0 1 0 1 0 1? Is it acting like that? No, it came and got stabilized at some value. But the assumption we made, what assumption we made? The assumption we made was K and Kp both were same, Vt also was same. Okay, so what this 2.5 volt is known as? This 2.5 volt is known as switching threshold of CMOS inverter. And what this circuit is known as? This circuit is known as self-bias circuit. What it is known as? Self-bias circuit. Why it is self-bias circuit? Because it is biasing himself. No, this was supposed to be your input, but we did not apply any input. We simply connected the output back to input. So what really happened? Because of this 5 volt, some voltage came here. That voltage came back to the input. Again, it started turning it on. It started turning on the NMOS. Basically, it is biasing himself. No, it is giving some voltage at the input on its own. We did not apply any bias from our side. We just gave 5 volt. That was our supply. We gave the supply. We gave the supply because of that capacitor charge. Then voltage came back. Then what will happen? Then what really happened? The NMOS was on. NMOS was driving some current. Then more voltage because of that NMOS. Sorry, initially PMOS was on. Because of that more voltage. Then NMOS also started turning on. NMOS also started driving some current. Then it started driving more current. Initially it was having 0.1 volt, no current. At that, then it developed 1 volt. Yes, some current is there. Then it developed 1.2 volt. Some current is there. Then it will develop 1.3 volt. Some current would be there. Eventually, it will develop 2.5 volt. So yes, it will drive good amount of current. It will drive the current equal to the PMOS only. So it is biasing himself. It is a self-bias circuit without even giving some bias, without even applying some input here. We did not apply any input. Because of the output only, it is being biased. So it is known as self-bias circuit, and it will have high power consumption as well. Sir, what is power consumption? So for that, I have separately made a video. Simply go to YouTube and type CMOS power dissipation PrepFusion Himanshu Agarwal, or power dissipation in CMOS. All the power I have explained: dynamic power, static power, leakage power, all these things, transient response of CMOS, everything has been explained. Complete CMOS has been explained. So simply go to YouTube and type power dissipation in CMOS by Himanshu Agarwal. You will get a video. You need to watch that video. That is also very, very, very important. Okay. So there I have explained the short circuit power as well. So there you would understand that if both of the PMOS and NMOS are turning on, then there will be very high power consumption. Because initially, what do you see? Initially at t equals to 0, I am talking about. This is shorted, no? So this is complete shorted and 5 volt is there. So this PMOS is turning on, right? Initially PMOS is turning on. So PMOS will turn on and directly it is connected to the ground. So it is almost like a short circuit path, no? Almost it is like a short circuit path. So almost it is like a short circuit path, so it will consume very high power. So it is a high power consumption circuit and it is neither behaving as a clock. Are you able to understand this point? So this is the scenario, this is the explanation that you can give. Now here we have taken some assumption that sir, Kp, Kn value were same, Vt value were same. What if they were different? In the examination they can say that Kp equals to or Kn equals to 2 Kp. This is what they can give, Kn equals to 2 Kp. Okay, let's just say this is what they have given. Okay, and let's just say Vtp value is mode of Vtp they have given as 0.5 volt and Vtn they have given as 1 volt. Now they will ask what will be the steady state voltage of the capacitor. What will be the steady state voltage? So how will you find out? What will be the steady state? Steady state will be the time when the capacitor starts driving 0 ampere current. What does that mean? That means the current in the PMOS and the current in the NMOS is same. This current is equals to this current. That will be the steady state, no? So what will be the steady state? When current in the PMOS equals to the current in the NMOS. What is the current in the PMOS? We need to find out the steady state voltage V0. We need to find out the steady state voltage V0. Let's just say steady state voltage V0 is nothing but Vx. Steady state voltage V0 is nothing but Vx. So both of the current I need to make same. So Kp by 2 Vsg. What is Vsg? VDD. What is Vsg? VDD minus this Vx voltage. Vx voltage I need to find out. Here I told 2.5 because I have made an assumption, right? So this voltage I need to find out minus mode of Vtp whole square would be equals to what? Kn by 2 Vgs minus Vtn whole square. Just equate them, get the answer. This value you would know, this value you would know, this value you would know, the ratio you would know, no? Kn by Kp ratio. So from here, this also you would know, this also you would know, you would get the value of Vx. If someone wants the expression, then this is the expression. Only mathematics, nothing else. This is the current in NMOS, this is the current in PMOS, right? So just 2 and 2 is getting cancelled out. Then we took the under root on both of the side. Then we took the under root, then this is the expression. Finally, this is the expression we get. Okay. And this particular point is known as switching threshold of CMOS inverter. What it is known as? Switching threshold of CMOS inverter. Now sir, what is this switching threshold? So if you have studied the characteristics of CMOS inverter, then you would know what I am talking about. Switching threshold of CMOS inverter. Characteristics of CMOS inverter. Have you studied the characteristics? Characteristics of CMOS inverter. I will draw it roughly only. So for a ramp input, what kind of characteristics you get? This is your V0, this is your V. What kind of characteristics we get? Initially, your PMOS will be in the linear region and NMOS will be in the cutoff region till V less than Vt. After that, what will happen? Your NMOS will go into saturation, PMOS will remain in linear only. After that, what will go? What will happen? There will be one time where both of them will come into saturation, and after that, the switching characteristics will change. Basically, there will be one point where the characteristics would change. Here, what was the scenario? PMOS was in, initially PMOS was in linear and NMOS was in cutoff. Then what really happened? NMOS came into saturation, PMOS remained in linear only. Then what really happened? PMOS and NMOS both came into saturation. And after that, the characteristics would change. So here, what is the scenario? PMOS in linear, N in saturation. So now what will happen? N will become in linear, P will become saturation. Here what is the scenario? That P is in linear and N is in the cutoff. So now what will happen? P will come in the cutoff, N will come in the linear. So after the point where this change is happening, no? This is the scenario, then both became same, and after that it is completely inverted. So where this inversion is happening, that point is known as, what it is known as, switching threshold of CMOS inverter. Switching threshold of CMOS inverter. So that value is also same. Okay, so it is known as switching threshold of CMOS inverter. So if someone would ask that if there is a CMOS inverter, I am connecting back I am connecting the output of the CMOS inverter back to its input, then where that capacitor will reach the steady state value. What will be the steady state value of the output? That will be equals to the switching threshold of CMOS inverter. This would be the answer. One liner answer if someone asks switching threshold of CMOS inverter. Now if someone in the interview, if you want to explain what you would do, what you can do is that you can make this characteristics. Now you need to know the explanation, why it is in linear, why it is in cutoff. So you would have seen that explanation, no? Complete CMOS inverter by Himanshu Agarwal, type on YouTube, you will get the explanation. Okay, complete CMOS inverter by Himanshu Agarwal, you can type on YouTube and you will get the complete explanation of these characteristics. Understandable? Okay, so you would know these characteristics. Then what you can say that, sir, you are connecting back the output to input. No, what you are doing, sir, you are connecting back the output to input. This is what you are doing, connecting back the output to input, right? Connecting back the output to input. This is what you are doing, sir. What does that mean? That means, sir, you are putting V0 equals to V in. V0 equals to V in. V0 equals to V in. So, sir, I have drawn the graph of V0 versus V in. Now, if you are doing V0 equals to V in, what I need to do? Can I draw the graph of V0 equals to V in? Yes, sir. The graph of V0 equals to V in would go somewhat like this. So, where both of the graphs are cutting? What is the point where both of the graphs are cutting? Both of the graphs are cutting at this point, and this point is known as switching threshold of a CMOS inverter. So, sir, the output will get stabilized at the switching threshold of CMOS inverter. Just by these characteristics also you can explain. Okay. So, if you feel like that it's been a very long time in the interview, 30-40 minutes has already passed, he has asked me this characteristics as well. After that, he is asking what if both of them are shorted. Then if this characteristics you have already made in the interview, then what you would do, you would again make it and then simply say that, sir, you are making V0 equals to V in. Simply draw this graph. This will be the point where both are cutting. That means at this point the output will be stabilized. So this is known as switching threshold of CMOS inverter. So if you are explaining this characteristics, then you would have surely explained this point as well, right? So you would say that your output will get stabilized at the switching threshold. Okay, otherwise you can explain in this manner as well, that, sir, initially this will happen, then it will start charging, at some point of time both will drive the same current, and that will be the steady state value. When they will drive the same current, sir, at this particular point they will drive the same current. Is that clear to you? Is that answer clear to you? Okay, so this was one of the video that was already I have made the video, but it was in between some videos, so it got overviewed. So yeah, now I have made a separate video. I hope it is completely clear to everyone. After that, what you need to do, you need to watch the power dissipation. Very, very, very important. Power dissipation in CMOS, very important. You need to watch that. Power dissipation in CMOS, very, very, very important. And then you will see the complete CMOS inverter characteristics and everything as well. Okay. And after that, your CMOS part will be completed, which is very, very, very important for VLSI interviews. Whether you are applying for IIT's interview or you are applying for industry interview, it is very important. Understandable? Okay. And this is the new t-shirt of PrepFusion. Yeah. This time we have gone with the yellow color, yellow, blue, black, and we will see what will be the next color. Okay then, yeah, thank you very much. Happy learning.